Hello, I'm Joel, and I've come all the way from Prague, Charles University Prague, in order to convince you all of a rather strange claim. The Unix Executable file is actually a Smalltalk method in disguise. What could such a thing possibly mean? And if it is meaningful, then is it just a random curiosity, or is it actually useful for something? By the end of this talk, I hope I will have convinced you all that this idea is meaningful and true, and also quite useful, or at least interesting. So over the past few years, much of my research has been concerned with programming systems and how to meaningfully compare them so that we can improve on them and learn from them. You can think of a programming system as a language plus everything else: editors, compilers, libraries, and runtime infrastructure for running programs. And as programming systems go, Smalltalk is an extremely influential and important one. Of course, a key piece of Smalltalk the system is a programming language, also called Smalltalk. But the integrated graphical environment that embeds this language is just as important as the language itself. And Unix is also a programming system. After all, some of the programs you can run in Unix are programming tools like text editors, compilers, and language runtimes. One unique feature of Unix compared to most programming systems, like Smalltalk, is that there isn't just one corresponding language. Instead, Unix is better thought of as a meta-programming system. So that's not a system for meta-programming, but a meta-programming system, which supports a plurality of other programming systems, which are in some sense smaller than Unix. And Unix and Smalltalk are both very important programming systems, but for very different reasons. And my good friend Stephen Kell has a classic article comparing the visions that these two systems had and the reality of how they turned out. Over the years, as I've read and reread this article, which is called Unix Plan 9 and the Lurking Smalltalk, it has wormed its way into my brain and my thinking, and greatly influenced how I look at these two programming systems. In a nutshell, Smalltalk is important because it serves as an aspirational example of a programming system that is nice. It's coherent, uniform, integrated, and it's very much designed. Yet, despite being so adored, and despite being so popular a few decades ago, Smalltalk has clearly lost various competitions of popularity or awareness or users, etc., to other programming systems. If Smalltalk was once a mainstream programming system, it certainly isn't anymore. On the other hand, Unix is important because it won. It's ubiquitous and we all use it in programming. To Stephen Kell, this isn't just a random accident, it's the result of some decisive survival advantages that Unix has over Smalltalk. And it's important to recognize that even on Windows, programming still occurs in terms of files and processes, which is an approach that's far more similar to Unix than it is to Smalltalk's fine-grained objects and messages. And later in the talk I will go into more detail on this difference, but the thrust of the point might be captured if we define a generalized Unix as follows. Software tends to be organized as a collection of large-ish files and processes, each of which contains a significant substructure which can be encoded completely differently in each case. So this last part on different encodings of substructure is referring to the gazillions of file formats and binary encodings of data structures in process memory, which Stephen Kell calls fragmentation. So the full article is very well worth reading, but to summarize what's important for this talk, Stephen goes on to identify a Smalltalk wish list of really nice things about Smalltalk that don't seem to exist in Unix. He then points out that many of these nice features do sort of exist in Unix, but in lots of different fragmented forms, or in ways that are just half-baked and frustratingly just manage to fall short of what Smalltalk has. And the reason for this frustration is that in Unix, these features evolved over time, whereas in Smalltalk they were designed in from the beginning. But to Stephen, Unix's evolutionary character is precisely the reason why we all use Unix far more than elegantly designed Smalltalk. He concludes by sketching various ways to continue to evolve these half-baked Smalltalk features towards their fully baked versions, without leaving Unix, and crucially, without requiring anyone to program in a particular way, such as by importing Smalltalk's class hierarchy or by mandating a particular language. And despite how much I love Stephen's article and agree with the analysis, it's this last point of programming a particular way that I'm going to shamelessly violate in this talk. because in January this year, I had something of a sudden epiphany, namely that this Unix Executable is a Smalltalk method in disguise, and following the implications of this idea led me to a new way to program in Unix, which I'm very excited about. So I also have my own Smalltalk wish list of things that I like about Smalltalk and other highly dynamic environments, and which are lacking in more conventional programming systems and languages under generalized Unix. For example, if I make an interactive application like a game or a web app, any progress that I make or any data that the app creates will eventually disappear until I write code to save it to a file. And then I have to write some parallel code to load it again next time. This seems to me to be the wrong way around. If I'm creating things or making changes, then I expect them to just stick around. I expect the effects to remain until I specify otherwise. And this doesn't seem to be in the Smalltalk programming experience. In Smalltalk, there's just a persistent universe of objects, and things that I create will remain there until further notice. Of course, the only Smalltalk I can actually run is a version that submits to the hegemony of generalized Unix. So when I close the VM, I get this message asking me to save. But I assume that if the VM crashes, then I lose some or all of my changes since the last save. I don't actually know how it works. But I have no reason to believe that this is essential to Smalltalk. And the important thing is that when inside the Smalltalk universe, I'm not writing, loading, and saving code at all. So persistence is the first thing on my wish list. Outside Smalltalk, when I'm writing, loading, and saving code, I'm also forced to choose how my program data structures are going to be serialized. Even if I choose an existing file format like JSON, I still have to decide how to encode my graph structure into a JSON tree. And the bigger problem is that other people aren't guaranteed to make the same choice as me. So we all use different file formats, and my program can't read their data even if it technically contains all the information I need. In Smalltalk, all structure is uniformly expressed as graphs of objects. And objects themselves are encoded by the VM in a way that I mostly don't need to concern myself with. So this uniformity is the second object of my envy. It's also very annoying to have to restart my application or game because I want to change the code or fix a bug. In many programming languages, it's not possible to update a program while it's running, or it's at least not easy. Of course, there's been a lot of research into hot patching and dynamic code updating in certain languages. But why doesn't Smalltalk need any of this? In Smalltalk, you can just browse to the method you want to change, edit the code, and feel the effects of the update anywhere the method is used. And it's been this way since the beginning, over 40 years ago. So dynamic software updating also goes on the list. And finally, GUIs in Smalltalk are completely different to GUIs anywhere else. GUIs are made of parts, and those parts are just objects like everything else. This means that Windows and graphical applications inside Smalltalk can compose with each other and collaborate in a way that seems to be very difficult in generalized Unix. There, GUI components are binary blocks in some unknown format, at some random address in the heap of a process. And this address, of course, is going to be different every time the application is restarted. And it can't even be accessed from other applications without special debug APIs, because applications live in different processes and process memory is private. So GUI openness is the fourth item on my wish list. Now, when Stephen Kell talks about his wish list, he goes on to notice that Unix actually has a great deal of the features, but not in a fully realized form. Similarly, when I followed in parallel and looked at my wish list, I saw the same thing for 3 out of the 4 items. Unix files are already persistent, and programs can read and write them almost as easily as process memory. There's only one type of directory, and it's used to uniformly structure the file system, at least until we get to the data files. And a running program can be updated as an entire unit without having to restart Unix. And this gave me a glimpse of something very interesting. So let's take a step back and analyze Unix and Smalltalk in terms of structure and behavior rather than what they happen to name things, and see what we might discover. So I like to start by noting that at a very abstract level, a programming system is just a dynamical system from physics. It has a current state, and this state evolves over time. For simple systems in physics, this state might be a single number or two numbers, but programming systems are complex and break down into lots of smaller subsystems. In Unix, the overall system breaks down into evolving subsystems that are called files, and they're organized in a tree structure. The file is the basic unit of state in Unix. And Smalltalk at this abstract level doesn't look too different. Its evolving subsystems are called objects, and they're just arranged in a graph instead of a tree. Notice that both of these are persistent. When you create a file, it sticks around until you delete it. The same is true for objects, except that they just get automatically garbage collected. What's responsible for evolving these subsystems? In Unix, the immediate cause of a change to a file is a write system call in the kernel. And this would have been triggered by a user mode API in some running process. The process was spawned from some executable file, and at this point we're back in the file system. So if we stay within the file system, we can say that Unix files are evolved by means of other files, executable files. If we turn our attention to Smalltalk, we can proceed in a parallel way. What causes a change to an object? Well, the immediate cause will be a bytecode. This bytecode was executed as part of some running method activation, which was spawned from some method. In Smalltalk, methods are objects, so here we've come back to the object graph. So, staying within the object graph, we can say that objects are evolved by means of other objects, methods. So with this picture so far, Unix and Smalltalk appear to share the same abstract structure in their persistent state. They both have a unit of state, the file or the object, and they both have a unit of change, which is just a unit of state which is marked as something special, an executable file or a method object. And so far this is in agreement with Stephen Kell's analysis. But in order to get to this conclusion here, we had to mention processes and method activations, which aren't part of the persistent state. So let's continue our comparison there and see if things continue to line up. What happens when we execute a file in Unix? Let's assume for simplicity that it's an ELF binary. Unix creates a process. It then loads portions of the binary file into process memory and starts execution from the entry point. From a dynamical systems viewpoint, this process is its own evolving subsystem. Just like a file is a subsystem of the persistent part of Unix, a process is a subsystem of the transient part of Unix. It's prepared in its initial state by the loader, and then it's set off evolving over time. And as we said earlier, part of this evolution can involve writing to persistent files. And these changes to files will probably be the only lasting evidence that the process ever existed, because processes are inherently transient objects in Unix. And interestingly, this transience of processes doesn't have a lot to do with the fact that they run in volatile memory, which will die if we lose power. Even if, like me, you hibernate your laptop all the time and effectively force this memory to be persistent, Unix processes are still transient. And this is because Unix has a policy that process memory gets destroyed after a process terminates. And what this means is that all of the data structures inside a process are doomed to be destroyed unless they are copied to a persistent file. Furthermore, let's note that process memory is a private address space, isolated from all other processes and difficult to access without specialized debugging tools. Now, what about the execution of methods in Smalltalk? A method activation is created and prepared in an initial state based on a persistent method object. Its execution is then started from the first bytecode instruction, and it forms its own evolving subsystem. Along the way, it can make changes to objects by sending messages or directly writing to its message receiver. And once it finishes, it will eventually be garbage collected, along with any local objects that it created which didn't get any references from the outside. Finally, method activations can only be accessed by special reflective features, so they are more private and less accessible, at least, than ordinary objects in the persistent graph. Isn't this an interesting equivalence? Unix and Smalltalk have both ended up with the same abstract infrastructure for evolving their units of state by means of throwaway subsystems. So why do they look and feel so very different? To answer this question, we'll have to look inside the files and objects. In Smalltalk, an object is a bag of state that can receive messages. But the format of this state is uniform to the programmer. It's a set of named slots which hold references to other objects which can be accessed in the Smalltalk language with the dot syntax. There is also a reflection API which can give you all of the object slots, which is used by the graphical object inspector and debugging tools. If we look at a Unix file, we don't see any uniform interface for substructure except byte access. A file is a stream of bytes. That's all that Unix gives us. Structuring those bytes is left entirely up to the programmer. If we need a file that contains the same information as a Smalltalk object, so basically a dictionary mapping keys to file paths, then think about how many choices we have for encoding that information as bytes. We have a gazillion standard text file formats that are often used for this purpose. Each of those began its life as someone's custom solution to this sort of data encoding problem. If we also think about how to represent this information inside a running process, then an unlimited variety of binary encodings confront us. And this is what Stephen Kell calls fragmentation. He says, Unix processes happily accommodate diverse implementations of language-level abstractions, but in the weakest possible sense, by being oblivious to them. Each implementation has to adopt its own mechanisms for object binding and identity, which are conventions for representing and storing object addresses. Another way of looking at this is that the operating system concerns itself with large objects only. In Unix, files and processes are large objects. They're expected to have significant structure inside them, and they all have to encode it in their own way. In Smalltalk, objects and methods can be large or small in terms of how many slots they have, but they all have this dictionary structure provided by the system. Any possible tree or graph structure in Smalltalk is objects pointing to objects. It's just a subgraph of the giant uniform object graph, and nobody except the VM developers needs to think about how to encode it. So, if we have a tree structure in Unix, we have no other choice but to somehow encode the tree as bytes, somehow. Or do we? Hang on a minute. Tree structures in Unix are ubiquitous. What were we just saying about dictionaries mapping names to file paths? Unix does prescribe a uniform interface for this. It's called a directory. And this is also echoed by Stephen Kell. He says, this unifying abstraction includes names and other metadata for all such entities, along with innumerable directory structures. Although primitive, this is clearly a metasystem. For instance, enumeration of files in a directory corresponds closely to enumeration of slots in an object, as expressible using the meta-object protocol. So if we're looking for similar structures in Unix and Smalltalk, then it certainly seems like directories are closer to objects than regular files. Both systems provide this dictionary structure mapping names to other basic units of state. And of course, in Unix, symlinks just let us generalize the tree structure to a graph if we so desire. In fact, if we were unfamiliar with Unix and using Smalltalk as a guide, then we might expect to find huge directory graphs terminating in primitive data like numbers or booleans stored in regular files. And this is actually something that does exist in Unix in the form of procfs, where the structured metadata of running processes is exposed as a directory tree, instead of a custom file format. But this is just the exception that proves the rule. We don't tend to see this approach in Unix, otherwise there wouldn't be any need for file formats. So while state in Smalltalk is made of millions of uniform objects, state in Unix is made of a few large files organized into a shallower directory tree. Hence the definition of generalized Unix as organizing software as a collection of large-ish files and processes with significant heterogeneous internal structure. The corresponding definition of generalized Smalltalk might be organizing software as a graph of millions of small objects and method, or method activations, with uniform structure. And speaking of processes and method activations, there's a parallel thing going on between them. A Smalltalk method activation is mostly bytecode, but it also has some private references to state, namely the temporary variables and the arguments. Of course, a Unix process contains executable code and command line arguments, but it's an awful lot fatter than a method activation. It's got all these subroutines and extra data structures, and it's even got its own stack. So the process might even be simulating its own object-oriented programming language with its internal objects and methods. What we would expect to see if a process really was the equivalent of a method activation is zero data structures, zero subroutines, no need for an internal stack, just a single main function that might write to external files. So it seemed that we had this really promising isomorphism between Unix and Smalltalk. In principle, directories and objects are essentially the same thing, and as are executables and methods, as are processes and method activations. But in actual practice, this beautiful symmetry is broken. Why is this? The answer becomes clear if we take this beautiful symmetry literally and ask what Unix would look like if it were programmed as if it were Smalltalk, Call such a vision small ticks. If a Smalltalk application is made of a million tiny objects and methods, and method activations are constantly coming and going, what's the corresponding thing happening in small ticks? Well, we have a million directories terminating in a million tiny files, and there are lots of small processes getting spawned and terminating every fraction of a second. Anyone who programmed this way will get fired immediately. It's a disaster. You just know it will be a slow, creaking, crashing mess. The unfortunate fact is that Unix is simply not designed to support many tiny processes coming or going, and entire galaxies of directories and files acting as data structures, whereas the Smalltalk VM is designed to support the analogous thing. There are opportunities for virtualization and optimization here. They clearly got procfs to work somehow, and Fuse lets you provide a file system interface to whatever you want, but I'm not aware of an equivalent for processes. Anyway, what if we just ignore all this? What if we just hand-wave away the performance overhead? Because programming in Unix as if it were Smalltalk appears to give me my Smalltalk wishlist for free. Persistence is automatic because all data access goes through the file system. There's no more writing code to load and save data structures from process memory. It turns out that Unix had automatic persistence all along. Because all data is encoded uniformly in the file system, it's all accessible by default, so all problems to do with not having the right editor installed or not having the right libraries go out the window. Turns out Unix had uniform data structuring all along. Dynamic code updating is really easy. Oh, that's the wrong order. Dynamic code updating is really easy. An application can be updated while it's running by recompiling a binary or editing an executable script. The next time that method is called, it will use the new code. Of course, what it means in small ticks for an application to be running is just that it has some state in the file system and that some of its methods are currently running as processes. And finally, GUI openness is achieved because GUI elements are now real addressable entities in the file system instead of obscure fragmented bytes in private process memory. Instead of dying with the process, graphical applications are automatically persistent and can compose more easily by referencing each other's components. In Smalltalk, the various browsers and inspectors and debugging tools all work together seamlessly in a way that graphical Unix applications simply can't, and it's because of this. What we're basically doing is viewing existing Unix infrastructure as a rough approximation of parts of a Smalltalk VM. We're hijacking the file system as object storage, and we're hijacking the program loader as a method activator. But many parts of the VM are still missing, such as the garbage collection and the basic primitive of message sending. These are the parts that we have to fill in ourselves. And I have actually implemented a basic proof of concept, which I will switch to now. So look at this. Is that visible? Yes. So I have in my code editor here, I have a file tree. I've got a bunch of objects. Some of them are normal objects, some of them are classes, implemented of course as directories, and some of them have methods which are implemented as bash scripts. What I've done here is in the Smalltalk tutorial book called Squeak by Example, there is a graphical tutorial example called SBE cross morph, and it draws this cross shape. And so it's made of a few objects and classes and methods, and one of the methods is horizontal bar. I'm afraid you're not going to see me draw anything, but the horizontal bar method, its job is to just calculate the coordinates of this rectangle that's the horizontal bar here. So it should give like coordinates for this corner and coordinates for this corner. So it's just a calculation, but that's what the horizontal bar method is supposed to do. And what I did was I just took all of the classes, which of course are objects and methods, and just ported them according to the Smalltalk connection into the file system. So for example, with the horizontal bar method, the Smalltalk source code is here, and I just translated it by hand into bash. So the intermediate sub-expressions had to get folded into these temporary variables, which is a bit ugly. But you can think of this as like a bytecode or a compilation target. And translating this meant I had to make some design decisions, like, okay, the first argument to this shell script, this method, is I'm going to pass self as the first argument. And I also had to implement a primitive send as another script, and also have a convention for tagged integers and floats, so that the thing would actually run in a finite, before the end of the heat death of the universe. So for example, if I show you the send primitive, ignore the big bit in the middle for the moment. This sets up some arguments at the top, and at the bottom we just bind the name of the message to in the receiver to a method, and then we invoke the method script on the right things. And then all this stuff in the middle is bash arithmetic for making things like this work. So if I want to send tagged integer 12, the message multiply by float minus pi, then I should get float that as a result. And don't ask me to explain this. I wrote it, but I can't explain it. So for example, I'll just show you a couple of things. So I've got SBE crossmorph methods. I had to go through from here and just look at all the classes and objects and methods that it would need for the horizontal bar method to work. So I went and pulled in and ported all of these other methods with the source code and then just translating it by hand. What else do I want to say? Oh yeah, because I was working on Windows to implement this originally, Windows doesn't allow colons in file names. So in Smalltalk, the message names have colons. I've translated that to dashes here. And the only method that's really substantially different from Smalltalk is object basic new, which creates new objects. So I just make dir object name and then increment the member variable called object counter. Object counter is currently at 1. And so the object we've got here is across. What is across? Across is a SBE crossmorph, which is down there. And of course, I don't have like metaclass hierarchy in, but SBE crossmorph does has a superclass, which is morph, which I had to implement somewhere. I could go on, but so it's a SBE crossmorph. So I think that's representing the entire bounding box of this thing. And it has a bounds variable, and what is bounds? It points to bounds rect. So what's bounds rect? Well, bounds rect is a rectangle, and it has a corner, which is bottom right point, and origin, top left point. Bottom right point is a point, which has a x and a y. So I am going to send across a message horizontal bar, and I'm going to assign it to result arect, and so then we will see it do some things. So send across horizontal bar, ready. Oh, that was quicker than I thought. So I've got tracing on. It clearly does a lot of work. Imagine all of the processes coming and going here. Oh, I didn't expect to scroll that much. Okay. Yeah, so what is arect? Arect is obj4, and look, we have some new objects that were created. So obj4, what is this? This is a rectangle, it's got a corner, obj3 and origin obj2, and of course these are points. And you're going to have to take my word for it, these are the correct coordinates, because I tested this, and so it gets the right answer. But you'll notice that there's an object left over, object 1, a point. And this was actually a temporary object that was created during execution, but there are no surviving references to it, so you know what that means. You need to garbage collect it. So, to any doubters, it works. And when I gave a lightning version of this talk earlier in the year, there was a Smalltalk user in the audience who stood up and said that it was the craziest thing he'd ever seen in his life. And I think it's worth being clear on exactly why this is crazy, because of the performance overhead. But I'm very optimistic that this could be improved by research on optimization, so fuse for the file system, and I've been talking with Stephen about some interesting ideas to take care of the process overhead. Which would make it not so crazy anymore. So you saw an example implementation of message sending and how I compiled by hand the Smalltalk syntax to bash, how I did garbage collection manually. So that was how we can program Unix as if it were Smalltalk. But it's also interesting to consider the generalized Smalltalk, where we make software out of many small uniform directory graphs and executables without necessarily doing anything particularly Smalltalky. So without the send primitive or anything like that. And again, because every language has an API to the file system, this approach is language agnostic down to the small executable files. We can write these methods using whatever language we want, because everything speaks file system. It's also interesting if we return to the size mismatch between Unix processes and Smalltalk processes. Smalltix processes. From the perspective of Smalltix, a normal Unix process with its stack and its subroutines now begins to look like some sort of specialized activator optimized for a specific tree of method calls. The objects referenced from the methods end up partitioned into several fragmented data files, and they're cached in a custom in-memory format inside the process memory. Of course, new code needs then inserting into the process to keep the in-process copies of the data in sync with the ground truth in the files. So that's these extra methods that have to be inserted here, the parsing and serializing code. But I think the most interesting insight is that it gives some insight into why normal Unix programming appears to lack the things I like, why I have to write loading and saving code in the first place, why I have to restart an application to update it, why runtime data is so brittle and inaccessible, and why GUIs feel so fragile and hard-coded compared to Smalltalk. Because we would observe exactly the same things in Smalltalk if we tried to squeeze an entire application into a single method. Methods are supposed to be these linear processes that accomplish a task and then terminate. But a graphical application is supposed to just be there for you to interact with. It should stay around as long as you need it to. Why would you ever insist on stuffing it into a single method and cause yourself so much trouble? So to wrap things up, Smalltalk is very nice, but Unix is what we're stuck with. What I'm stuck with. Unix and Smalltalk look very similar at a high level. Directories resemble objects, executables resemble methods, and processes resemble method activations. Unfortunately, these equivalences are only true in theory and not so much in practice. This is because Unix files and processes are heavyweight. They can't be fine-grained like Smalltalk objects and methods. But if we use files and processes in an ultra-fine-grained manner, we get Smalltalk conveniences for free: persistence, uniformity, dynamic software updating, and GUI openness. Practical experiments have been promising so far, and optimization possibilities exist. More research is definitely needed. And lastly, make sure to come along to the poster session later if you want to see me attempt to explain Unix, Smalltix, and Smalltalk side by side in a big, complicated diagram. Thank you.
Afterward, we can look you up.
Yeah, I have a few points on the differences between Smalltalk and Unix. I'm sorry. So one is protection. Access control is a crucial thing for operating system, but I don't think Smalltalk has it.
Correct.
So
Smalltalk doesn't seem to.
What do you think that's the difference?
Yeah. So Smalltalk does not appear to have access protections on different entities inside it, whereas, of course, access protections are very important for operating systems. Yeah, that's a difference. But it seems like access protections are kind of a special case that you normally just normal files and processes seem to be, everyone gets to read them. I'm aware of that, but I don't know if it affects the interesting idea very much.
Yeah, I'm wondering what happens if you introduce access controls into Smalltalk world rather than.
Yeah, I'm also interested in what happens when you introduce access control into Smalltalk, but I don't know about that.
The second difference is if you choose a Smalltalk, you have to use Smalltalk only. But if you choose a Unix, you have a freedom for the choice of programming languages. So what do you think about that?
Well, yeah, so this is a very interesting point that Stephen makes in the article, and I'm not sure. It's certainly true in practice that in Smalltalk you only have the Smalltalk programming language as in a syntax, but it doesn't seem to me to be prohibited. It seems to be encouraged or certainly permitted in Smalltalk to provide your own syntaxes that would compile to the same bytecode. It just seems that people don't do it in practice, but I don't see any barriers to doing that. So it's definitely worth. This is a question that, if you try and answer it, you find out what the real kind of differences are between Unix and Smalltalk.
Yeah, because the beauty of the Smalltalk world comes from everybody uses a single language. So
but does
it's easy to reuse the existing source code and etc. But in the Unix world, it's more like a Tower of Babel.
Yeah,
so
Tower of Babel, yeah.
Sometimes it's very difficult to use a scheme code for, let's say, C programmers, vice versa. So that, I think, it's, I think that's a very crucial cultural burden to reuse old components. But in the Smalltalk world, everybody has to use the Smalltalk as a single language. So that's why everything is so smooth. And
I'm skeptical of that. I'm not sure about that. The integration and uniformity of the Smalltalk experience is certainly due to the common bytecode or the common object model. But I don't know if we're talking about the Smalltalk language as the Smalltalk syntax, then I don't know if that's so crucial. I mean, you mentioned like source code version control management. I think they do have textual version control, so it's clearly important for that. But I'd want to thoroughly grill a Smalltalk expert on that question because I'm skeptical that it's quite as simple as that.
Hi, I found your project really, really fascinating. But after having spent 3 days at ICFP, I'm convinced of the superiority of functional programming. And I want to
Were you not already?
And I want to propose to you the idea that maybe this is going in the opposite way that things should be going in. Like equating Smalltalk to Unix is not the way to go. And instead, we should be equating Unix to something like Haskell or OCaml, where you have. Yeah, I mean, in fact, I think in the past, we've already had these massive Unix pipelines. Unix pipelines is kind of one of the signature features where you have a basic, almost purely functional pipeline that produces some things in a lazy sequence that is only actually read when another process reads from that pipeline. And we've seen these massive pipelines being composed and actually working, and I think prior to systemd, this is as far as I understand, how many things were done in Unix and Linux. So my question is, should we not invest more in that direction to provide maybe type safety for these pipeline commands, rather than investing in optimizing file system operations so that we can have even more mutation and more statefulness?
No, I want resources to pursue this thing because I'm really interested in it. I'm not going to say that thing is not valuable. I think we should do both. But I'm afraid I'm not interested in types and making Unix more like functional programming. I'm more interested in this. So if I have to choose what to do, so it's good luck with that. That's. I hope that's successful.
Good luck with your endeavors as well.
Thanks.
Hello, thank you, Joel, for a very exciting and stimulating talk. So this is Alan Perlis' epigram, right? Beware the Turing tar pit, in which everything is possible, but nothing of interest is easy. And my question is, have you fallen into a tar pit where kind of in small ticks, anything's possible, but actually it's jolly difficult?
Well, the only difficulty I can see is performance related. But the translating of things from Smalltalk to Smallticks, I mean, kind of by design, was so.
Well, your bash scripts didn't look terribly simple.
Well, they are compiled code. Like my vision would be you have Smalltalk code in the files and some automatic the process of translating them was so mechanical. It was trivially automatable. I just did it all by hand because it was a small scale problem. So I would never think that those bash scripts would be the thing that you see as a user. To me, that's the closest thing to binary, unreadable binary code that we have in this way of doing things.
Okay. Thank you.
Stephen.
Hello, Joel. Thank you for the talk, and thank you for taking my work very literally.
It's okay. You can send me the money later. I won't tell anyone.
I suppose I'm going to ask about your top bullet. There's many things I could say. I think about the top bullet of your conclusions, right? So we're stuck with Unix. That's definitely a position I've sort of espoused, but it feels like what you're doing, and you mentioned this at the beginning, you're picking one way to encode Smalltalk concepts into Unix, but you're not necessarily doing the converse, which is to say all the funky ways people have come up with to do vaguely Smalltalk-like things in Unix. We're not trying to lift them up to recognize them in a first class way. We're just saying, well, here's one way you could use it, right? Which is fine, and it's impressive how far you've been able to take this slightly crazy idea. So that's definitely respect. But I wanted to know, are you planning to build anything seriously with this? Like, do you have projects like, here's the thing I want to build using this system?
I want to push it as far as it is able to go. So I want to see. I in my head I thought, oh yeah, this will just work, except for modulo performance. So I thought, I wonder if there are any other difficulties, reasons why this actually can't work in practice that I haven't thought of. So then I made this small demo, and it worked perfectly well, except for the performance, which is a known problem. So now, at the end of the paper, I said, okay, I plan to continue to port the rest of the SPE crossmorph demo and set up a way to render things to a web canvas or something, so I can actually see things render. What happens when I push it to be like rendering frames per second, or probably more like seconds per frame in this case, and do input handling. I don't see, and I think I'm kind of daring this to be a way for me to enjoy Smalltalk stuff without having to be sequestered inside the VM or image. So any project I might want to do in Smalltalk, I could just do in Smalltix instead, and I might not even have to use the Smalltalk syntax. And of course, think of generalized Smalltix as well. It's I haven't tested this yet, but I want to really push it and see where it breaks. So I do think this is I'm daring it to work, or I'm daring it to break. I don't know, both.
Thanks. I think I had a follow-up, but I've temporarily forgotten. So I'll talk to you later. Oh.
Okay.
Thank you for the talk. That was very interesting. So you just answered part of my question, which was about the actual rendering of the GUI. I guess my other question is, have you thought about actually comparing the performance of, like, for example, some simple GUI program written in Smalltix against a web app or a React, like an Electron app, or maybe like a GTK app? I guess the point I'm making is, the conventional way of writing a program as a single monolithic process, it allows the program to be very performant, but it doesn't prevent you from writing a very slow program that is unnecessarily bloated and trips over itself.
Like Electron.
Exactly.
Okay.
Yeah. So I guess it would be interesting to see if making it easier to build things from scratch, build things out of small components that you understand. If even with this performance handicap, if like that benefit can actually help you do better than the conventional tools that have like kind of grown as much as they can given the computing resources.
So you mean if I just solved the performance problems, then it would be interesting to see if it would be funny if this was like more performant than Electron?
Yeah, or
something.
even like without. I mean, I think if you're using a web canvas to render, that might be an issue. If you find like some quick way to render it, Like I wonder if like doing things in Bash and using the file system, that might not actually slow you down as much as as you might think. Especially now with modern hardware, it would be interesting, I guess, if like even misusing the Unix API, allows you to do better than like the conventional tools. I don't know if it would.
Yeah. I mean, I don't expect it to until heavy work is poured into optimizing it. But the advantages are the 4 nice things on my wish list. That's the main. Like, I'm willing to take the performance hit, so I don't have to deal with all those things.
Yeah, hi. Are you familiar with the Windows registry?
I have ventured in there occasionally, armed with heavy weapons. Yes.
Yeah, because it occurs to me that like some of the properties you want are there, like persistence, uniformity, dynamic software updating, not GUI openness, but those other 3, I think.
Sure, but is this not because the Windows registry is an instance of a database, like any other database?
But it kind of just reminded me that you're building these directory structures with the data in it, and that seems to be very similar to what the Windows registry is trying to achieve. And
you give me some ideas now. I'll have to do it in a VM though.
Anyway, it was just a comment. So.
Yeah, so that's another directory substrate. But of course, the registry is associated with all these dangerous things. I don't think there's a safe analog of the registry, which is weird because random program configuration is like mixed with deep system configuration, right? That's why it's dangerous. It would be interesting to abuse the Windows registry for this in a suitably safe environment as well. Maybe it would port directly over there as well.
So I want to ask about universality. So, pretty much every non-trivial data structure has some kind of invariant, right? A JPEG file, despite being a bunch of bytes, has to have the JPEG data structure. And you can have lists of pairs, and, they have to be paired, right? Whatever your invariants are. And you can choose to not write them down, and then you end up with something untyped. Or you can choose to write them down informally, and then at least you have some documentation. Or you can write them down in some formal structure. Whatever structure is there, affords manipulation in some way, right? So if you just have a binary file, you can go and tweak the bytes, and you might break some invariants, but you can tweak the bytes. Or if you have Smalltalk objects, you can go and tweak the fields. You can see what the fields are, and you can see what they're named. And maybe the names mean something to you, and maybe they don't. But you can edit the structure. But you might violate some invariants, unless there are some constraints. So I guess I'm trying to understand what you mean by universality, right? Because you can see that there's some structure.
Sorry, do you mean like generalized Unix, generalized Smalltalk, or what universality? Like the universal object graph of Smalltalk?
Right. So you're saying it's great if you use this object graph because it's universal in this way. But if you edit it in the wrong way, then you might break invariants. Just like if you edit the bytes of a file, you might violate some invariants.
That's correct.
So I guess I'm trying to understand what you buy by doing it the Smalltalk way.
It's a base layer of uniformity for a very common structure of mapping names to other basic units of state. So you're right that even within the universal object graph, you've got this. There are like these layers of format or layers of syntax building on top of each other. So even in Smalltalk, certain arrangements of objects are valid, like GUI structures or a specific. There is additional structure that you can break if all you have to available is a tool to edit the object graph as an object graph. A bit like a hex editor editing a binary file. It will be a valid hex file, but it won't be a valid according to the file format.
So why is this the model of your dreams, as opposed to, I don't know, a JSON file or a relational database? Or you could pick your universal structure that provides some structure and some transparency.
I think because in my experience I've just found everything I make ends up wanting a base layer of a graph of dictionaries pointing to each other. And in generalized Unix, you don't even have that, or you have to pick a specific encoding of that, which is incompatible with others. So just this thing that I always need, if it's prescribed by the entire system and everything speaks that language, then it's a better foundation. But it certainly doesn't go all the way to solving the problem of these syntaxes and formats all the way up. But it at least gets the base layer. It makes that uniform.
So I wonder if there's a way of lifting this past sort of individual opinions or experiences into some sort of empirical study or empirical analysis of what is the right substrate, or for each context, what is the right substrate?
I guess so. Yeah. Yeah, I don't have any ideas of how to do that, but that would be it'd be nice to have that, yes.
Any last remarks? Okay, well, let's give one last round of applause. Thank you. Okay, next up is our coffee break.